Hi guys, this is the third module. It consists of three parts: clipping, 3D geometric transformations and illumination models. The clipping part discusses about how an object will be clipped and displayed in the display window using the clipping rectangle or clipping window. The 3D geometric transformations is an extension of 2D geometric transformations that you have learnt in the second module. And the illumination models discusses about the surface rendering of an object, that is, for example, the reflection properties of an object. So let us go to the first part of the module, which is clipping. The clipping window is by default a rectangular shaped window which is aligned with the x and y axis. So here, if you want to have a different type of a clipping window like hexagon shape or rectangular shape, you can define it using OpenGL functions, and by default for the rectangular clipping window we will be giving two set of values. Those are nothing but the diagonal corners, or you can say the opposite corners of the rectangle, which is represented by x min, y min, x max and y max values. So here, to get a rotated view of a scene, in case you need to have a rotated view of a scene, you have two options. Define a rectangular clipping window in a rotated viewing coordinate frame. So it is nothing but you are supposed to define a clipping window in a different axis, which is called as viewing coordinate frame. So this frame will be actually rotated with respect to or in relation to the actual xy coordinate, which we call as world coordinate axis. The world coordinate axis is nothing but the one which represents all the objects together that you have defined for the display. Or you have the second option where you can directly represent your object in the rotated vertices format. So here is a sample in which you have y view and x view coordinate axis rotated. So this is how I want to actually represent my object. So in order to do whatever operation you want to do with respect to the object represented in y view and x view coordinate axis, you are first supposed to bring it to the reference of the general xy axis. So this here is called as x world and y world. As you can see, the x world and y world coordinate axis are aligned with the xy coordinate axis. So what do we have to do? What I want to display is in clipping window, which is actually in the rotated form. If you want to apply any operation on that particular object, all the standard operations are defined with respect to the standard xy directions. So you are supposed to bring that viewing coordinate axis to the world coordinate axis. So that's what we will do in the next operation. As you can observe, the top figure represents your initial state of the coordinate axis. If you need to apply any operation with respect to the object defined in the clipping window, you are supposed to bring that viewing coordinate axis to the world coordinate axis. The first step in that is bring the viewing coordinate axis to the world coordinate axis in such a way that the origin of the viewing coordinate axis coincides with the origin of the world coordinate axis. That step is called as translate step, which is represented by capital T in the second figure. There you can observe the origin of viewing coordinate and the origin of world coordinate are coinciding at the same location. But here you see the viewing coordinate is having some angular difference compared to the world coordinate axis. So what do we have to do? We have to rotate the viewing coordinate axis in such a way that the x and y axis of viewing coordinate system overlaps with the x and y axis of the world coordinate system. So we will be rotating. So the first operation is the translate transformation and the second operation is the rotate transformation. As I have already told you, while representing in the matrix format, we are supposed to represent the first operation on the right hand side or the right end of the equation, followed by right to left direction till the last operation. So in order to obtain the overall matrix for this operation, we will be writing r dot T. So the matrix M, WC, VC, world coordinate and viewing coordinate equal to R dot T. As you can observe here, T is represented at the right hand side, which is the first operation, translate operation. Dot, the last operation, is the rotate operation. Here is a sample to represent the same thing with respect to the object. Now we discussed with the coordinate axis system. Here we are considering the object. So the object should have some reference point in order to apply those operations, translate and rotate. As you can see here, there is one point taken, x0 and y0, which is highlighted in the triangle, which is oriented. Every object will have some reference axis. So for every object we are going to take a v vector, which is actually similar to the y view. So it is in relation with the y direction of any axis. So for this triangle, the v vector acts as a y vector. So now x0, y0 is a reference point. In order to perform the same operation, we have to bring the object to the x world, y world coordinate axis in such a way that the x0, y0 overlaps on the origin of x world, y world axis. After bringing that to the origin, we are supposed to apply the rotation to the triangle in such a way that the v vector overlaps with the y world vector, that you can see in the image B. So that's the final state of the triangle after bringing and rotating it to the x world, y world coordinate axis. And the clipping window is around the object. This is defined with the maximum and minimum value of the triangle that is present. So in order to create a clipping window for any object which is defined in a different viewing coordinate axis, we can take the coordinate extents of the object. The coordinate extents of the object is nothing but the minimum and maximum value for x and y directions, and hence once we have this minimum and maximum, we can set up the value for clipping window with the help of x min, y min and x max, y max values.